Hello, friends, and welcome back. We are here for another virtual MOSI. My name is Ian Reed, and today we're going to discuss heat and convection currents. This is going to be really neat. This is something that I also saw online. It's just really cool. So let's talk about convection. So what is it? Well, if you look at my nifty picture here. So this is basically what happens. You have warm air which rises and cool air which sinks, which causes this wonderful current, this wonderful flow of air. And so as the warm air rises up, it cools down, the cooler air is sinking, you get this cycle which actually causes weather phenomena in our area. All right. So boom! Thunderstorms are actually caused by convection. It's actually called convective precipitation. And what that basically means is, if you recall from yesterday, we talked about evaporation, where the liquid becomes water vapor, gas, and it rises up. Well, in convective precipitation, what happens is as it rises up vertically, building up clouds, and it gets larger and larger until you have this wonderful picture like right behind me. And we talked about how, thanks to condensation and saturation, the massive clouds get really large, and so then you get thunderstorms, things of this nature, and that's due to convection. Now, don't be afraid, don't be frightened, because convection is actually helpful. See this picture? Scientists have actually said that without convection, our average temperature would actually double. So the average temperature on the Earth is about 59 degrees Fahrenheit. Without convection, our average temperature would be about 125 degrees Fahrenheit. All right, so convection does have a great purpose as far as regulating temperature here on the Earth. And so we have a couple of things that we can do to kind of show how this works. So I have this wonderful apparatus right here. And so what we have are two hot plates. One hot plate has hot water in it that we've been heating, so now it is pretty warm. All right, on the other hot plate, not plugged in, but it has a lot of ice in it. And so what we're going to do is we're going to use food coloring. Red we'll place on the hot side, the hot plate that's plugged in and heating the water. Blue we'll use on the cool side, which is being undergirded by ice. All right, so we're going to put a few drops in there. We're going to see what happens. Now, to do this at home, you don't have to have my magnificent apparatus here. I'll show you what you can use. All right, so for the hot side, we're going to place several drops. Red food color in there. Cold side, we're going to place several drops. Food coloring of the blue. Notice that the blue is sinking. Side is rising. All right. And so what you are seeing is that cycle. So as it is being heated, the red dye representing warm air is actually cycling this way. And the blue dye representing the cool air is kind of sitting, but as the cycle begins, and we'll just cut up just a little bit, you will get your convection current there. Now, convection only stops, this cycle only stops when the air around it actually gets cooler than it. So that's what stops it. So now you're seeing here what we call a convection current there. All right, so you can see it here as well as on the top, the flow. So you're seeing again the red dye kind of rising up, and notice the blue now coming over and mixing. And so you're getting this wonderful cycle there. All right? And so it's because of this cycle that we get, again, our weather phenomena that we have, especially here in Florida where it is really warm. Now, here's something that's really interesting. So what I have here, I have these wonderful thermometers. And so what we want to do is we're going to use these thermometers and we're going to check both ends of our apparatus here. So turn this on. It's on. Okay. See, both in Celsius. Remember, science, metric. So what we're going to do is we're going to place one. Now here's a hint. When you measure the temperature of something, you never want to push it all the way down. You want to kind of have it there. You don't want it to touch the bottom because that gives you a false reading. So on the cooler side, right now, it's rising to about 30, and so about 30 plus degrees. And so if you notice, on the warmer side, it's already at 31 degrees. So there is a slight change there, even though you have a cooler side here and the warmer side there. Okay, and so what I'm also going to do is just show you the different sides. So remember, convection stops once in this case, would be the water around it. It's about the same temperature. So if I were to place this here, just in the midst of the ice, you're going to see a drastic temperature drop there. Look at that. We're almost below zero. How cold that is. Right? And we are below zero. Look at that. All right. And if I were to carefully slide my apparatus over just a tad, likewise, you see a tremendous temperature jump there. All right. It's almost there. Do it, do it. Almost, and bam. So we're definitely at what we would call boiling for this one. And so that's it. Now if you don't have this and your parents are like, wait a minute, how do we do this on the stove? Here's another way to do it. All right. So let's say we're going to take a container. Again, you want to do this with your parents. We don't want anyone to be burned or anyone to get hurt. Pour that, like so. A few drops. Notice what happens to the water there. And if we were to take ice, all right, this is there. All right, you saw the drastic mixture there. Well, what we were trying to do is to get it to separate, but if you do it a little slower, you'll get something kind of similar there, instead of purple juice that we got. But if you do it just a little slower and just use a little bit of blue, you'll kind of get your convection as we saw here. And so, again, that is how we get, from the convection currents, how we get our weather phenomena. Again, especially in Florida, with hurricane season coming up, Hurricane season starts Monday and ends in November. And so you'll be hearing a lot about different types of currents. You'll be hearing a lot about high pressure and low pressure and things of that nature. So think of the amount of warm air and cool air as it cycles. Also evaporation, which causes storms to get stronger as well. So thanks for tuning in today. Appreciate everyone joining us. Hopefully you learned a little something about convection and weather. Tune in with us tomorrow. We'll have more fun stuff. This is Weather Week, and remember, keep discovering.